Hi, and welcome to today's webinar. Thanks so much for joining us live. I'm Catherine Stapleton, webinar specialist at AWWA. And before we get started, I just want to go over a few tips and tricks to enhance your virtual experience in ON24. Please close any programs not currently in use. This will free up processing and increase bandwidth, speeding things up and strengthening your connection to prevent crashes. While technology glitches can happen, note that most common webinar issues can be resolved by simply refreshing your browser. If you do encounter a problem, such as frozen screen or loss of audio, please refresh the page before attempting to troubleshoot. As you explore the attendee console, feel free to move things around and adjust to your preferred view. All of the windows and widgets in your browser are customizable. Just hover over a window to display the toolbar, allowing you to minimize or hide, resize, adjust volume, and turn on closed captioning. Let's take a look at your toolbar. From left to right, the first icon is Presenters. This will open up your media player. Here, you can adjust the volume and turn on closed captioning. The Slides icon will minimize or maximize the center window with a live view of the presentation slides. Submit a question to the panel will open the question pane. We'll hold a Q&A session after the presentations, but questions can be submitted at any time. By default, you'll find the question pane located directly underneath the slides. This presenter information icon will open up speaker biographies and contact information for today's panelists. The purple icon will take you to AWWA's Events and Education homepage. Here you can check out upcoming webinars and events. Here you can access the attendee chat. We encourage you to use this tool to interact and share information with your colleagues. You can also reach an AWWA representative in the attendee chat. They're going to be available to answer any technical or webinar-related questions. This paperclip icon opens up your additional resources. Here, you can download a PDF of today's presentation slides. Reactions will allow you to share emojis during the live webinar. This thumbs up icon will open up the webinar survey. The survey will also pop up as soon as the webinar concludes. Once you've met the attendance requirements, this ribbon icon will appear, allowing you to download your AWWA Certificate of Completion. I need to inform you that the mention of specific products, services, or opinions expressed in this webinar do not represent AWWA endorsement. AWWA does not endorse or approve products or services. With that, I'll hand things over to your moderator and panelists. Thanks so much for tuning in and enjoy the webinar.
Hey everyone, my name is Claire Moffitt with American Water Works Association, and I will be your moderator for today's webinar, Tackling PFAS in Minutes, sponsored and presented by Transcend. Before we jump in, I just want to do a quick introduction to our presenters, which we have here. Our panelists will be Dr. Analia Faznisa, Advisor of Transcend. We have Adam Tank, Chief Customer Officer of Transcend, and Nick Mehta, Applications Engineering Manager at NX Filtration. So with that, I would like to pass it off to Adam.
Excellent. Thank you so much. And thank you to everyone who has joined the webinar today. Sounds like it's a pretty full room, which we're excited to see. PFAS is obviously a big topic and one we are going to get into some really fun details about. Fun, obviously, maybe not the best word. This is a very challenging problem that we are all trying to solve. Fun in the sense that there are some new innovations that have now come to market, both on the design side and the treatment side, the membrane side, that we're going to get to talk to today. So before we get there, I want to talk briefly about what the goals are. What are the goals for this webinar, and why are you here, and what can you expect to learn? So the first thing that I wanted to say is that you will have direct access to some of the world's leading PFAS treatment experts. So Dr. Angelita Fastenacht is an incredible water industry expert overall. She spent a bunch of time at utilities, a bunch of time as a consultant, and has studied the PFAS challenge very deeply. So she'll be able to answer a lot of questions. Nick as well comes from one of the most cutting edge membrane companies in the world, in my opinion, at NX Filtration. Both of them will get a chance to explain what they do. And of course, again, you now have access to them. I want this to be a conversation between us and you all. So please use the Q&A feature, use the chat. We'll be sure to answer your questions as we get them, and we appreciate the engagement. The second thing we're going to show you is an actual real demonstration of how a utility or engineering consultant can use software to automatically determine how long is a PFAS treatment project going to take, and how much is it going to cost. And we'll show you how easy it is to answer those two questions using software like what Transcend has developed. And then finally, you're going to get a chance to hear from Nick on the nitty-gritty about a novel approach to PFAS treatment with a very unique membrane technology that NX Filtration has developed. And so I hope that you are able to engage, again, ask questions, and make sure this is lively for all of us. We're here to have a conversation around PFAS. So to start, Angelita, would love to hear from you and your journey and why you're here today.
Thank you, Adam. Well, very nice to be here. Thank you for having me here in this webinar. So who I am, I came from a very beautiful country, specifically where I am today, actually, Colombia. Moved to the US 24 years back, and for 30 years I've been working in the water sector until probably most recently when I pivoted to a different area. So been working worked in Colombia, worked in East Africa, worked in different type of environment, including large utilities, large solutions for municipal and industrial. So I listed all the many companies I've been and universities that I've been at as well. So I also was named a fellow at Princeton University. So I'm associated with Princeton, where I also teach. And that has given me the opportunity to explore other areas in the sector besides water. And so that put me still to say, okay, we still have an issue, which is the PFAS. And I know that there is an opportunity for us to come together at this point and then use the best of the technology to solve those as much as we can. So from the operational perspective, that's one side, but also from the design perspective, which is another place where I see I saw a lot of bottlenecks happening. So that's a little bit about me.
Thank you. And now Nick from NX Filtration.
Hey, yes. Thank you for the introduction, Adam. My name is Nick Mehta. I'm the Applications Engineering Manager for North America for NX Filtration. I've been in the water treatment industry for about 10 years now, working for a variety of different membrane manufacturers. So here I'm here to introduce to you NX Filtration and our membrane technology solution, specifically to tackle PFAS. I'll just give you guys just a short introduction to NX Filtration if you don't already know about it. NX Filtration is a membrane manufacturer specializing in patented hollow fiber nanofiltration membranes. We're the only company in the US market with a commercialized hollow fiber nanofiltration membrane for large-scale municipal and industrial water and wastewater treatment. This slide kind of just gives a little summary of our exciting journey so far. These membranes were first patented by Dr. Eric Rosink, and he went on to co-found NX Filtration, and he still acts as our CTO. The company has grown rapidly, especially since its IPO in 2021. The company's headquartered in the Netherlands, and just last month opened its new mega factory production facility, making it the largest membrane production facility in all of Western Europe, with a future production capacity over 120,000 membrane modules per year. This is allowing us to fill larger and larger orders, including the largest hollow fiber nanofiltration membrane plant ever at 9 MGD in Mexico. So yeah, thank you to Transcend and AWWA for including NX in this webinar. And maybe towards the end of the presentation, I'll give you guys kind of a little walkthrough of how our membrane can be used for PFAS treatment.
Excellent. Thank you, Nick. We already have a question about PFAS and membranes, so I think you're going to be busy during the course of the webinar. We'll be sure to get it answered as your section comes up. So thank you.
Definitely.
And then finally, yours truly, Adam, sort of serving as an MC of sorts for this webinar. I'm loving the emoji reactions in this. I feel like it's so hard to communicate when there's a couple hundred people on a webinar online. So every little thing, the Q&A, the chat, the emojis, that all helps us keep our energy up and hopefully keep everyone entertained. I co-founded a company called Transcend in 2019. Almost hard to believe we're at 130 people now, and we are a team of licensed water, wastewater, and power engineers who are excited about the prospects of software to help us build more sustainable infrastructure. What that means is that with a limited number of inputs around a project, your influent quality or effluent quality, the treatment technology you're using to treat the water or wastewater, you can press a button and get a complete set of engineering grade documentation automatically. I'm talking about equipment lists, civil BOQ, a CapEx calculations, OpEx calculations, a technical description, preliminary engineering report you'll hear is a common, a term commonly used in the consulting engineering industry. These types of things can now be generated automatically, which ultimately gives utilities and consulting engineers more data to make better decisions about our projects, whether that's reducing the total capital cost of a project, whether that's improving the operations, that could be reducing the carbon footprint, the site footprint of plants. There's so many different variables that you can consider when you have software that's doing a lot of what we call grunt work or repetitive, routine, monotonous work. Our company is global. We've run, projects have been running our software in over 70 countries to date. We've impacted more than 360 million people using our software. So that means our designs running our software have positively impacted folks by getting them access to clean water, treated wastewater, or renewable source of power. And we've raised over $35 million to date to do this, including one of our investors, Autodesk. Some of you may use some Autodesk products, whether that's AutoCAD, Revit, or others. Very, very close partner of ours, and we're excited to be helping change this industry and transform this industry digitally. All right, so to get into the meat of things, some of the challenges with designing PFAS treatment systems today, and I really want Angelita to speak to this because she has so much boots on the ground, dirty hands, if you will, in managing some of these challenges. But across all of these segments, and I'm really curious for those of you that are here, which of these buckets you fall into, and maybe you fall into another one. I'd love to hear it in the chat. Whether you're an asset owner, an OEM, or an engineering consultant, we are all facing extreme uncertainty relative to this PFAS challenge and how we're going to tackle it. So Angelita, would love your thoughts.
Absolutely. So it is absolutely a need for all these three buckets. And yes, as Adam said, it would be interesting to see if there are more applications. But for asset owners, for instance, we have to make decisions on our budget, right? And we have a very tight budget. That's granted. For municipal water or locations, we are based on rate base, and that makes it a little bit stricter to be able to make decisions on what to spend, how much to spend, and then the approval processes and all the permits that he have to go over, including the permits with the municipalities and with the communities that they build it on. So there are a lot of variables that are included in there, and the design on its own could be very rigid, because once you make the decision, that's it, right? Changing that will increase again your cost for design, and there may be some changes, but there are some changes that could be identified before the design is fully executed and all sealed. So this tool really offers that opportunity to be able to assess risk, almost like tailor your address to yourself, instead of just buying something and then having to make a modification. This will be able to have the asset owner saying, okay, I like what I see, where I see the solution, how large the solution is, and will make them prepared to, okay, I need to start talking to specific permit or specific communities that may or may not be liking the location of where the solution is going to be. So that's one thing for asset owners is really a fantastic tool to be able to make those decisions on time, not waiting for the 30%, 60%, 100% of a traditional design engineering. For OEMs and integrators, another great opportunity to be able to say, listen, I have my vessels or my the solutions that are being provided. It is typically needed to be customized for clients. But if there is this tool already at the hands on the OEMs or the vendors that we are using, as a client perspective, it is much easier to see it and to visualize it. And it's nothing better than presenting to your potential client, here's what the type of vessels, the size of vessel that we have, and then in a way that you can really move your vessel physically in your graphic, in your design, you can really move it and start making modifications as we speak, as you sit with those vendors and start making modifications that you need to make between owner and vendors. And the last is for engineering consultants. Absolutely, there is nothing, engineering consultants, everything has to be optimized, right? Your time needs to be optimized. And having to go back and forth with your client because, oh, there was a change and no, that's not enough time, or just seeing these, perhaps bringing these in a tablet and then sitting with your client in a facility already and start running the scenarios and the conditions and seeing it right there. It is a fantastic way to be able to visualize and ask questions at the moment and then iron out situations that you may need to iron out by email. So instead of doing that, do it face to face with your tablet, with your information in there. So that to me is Transcend has offered a really, really great solution that is really making more efficient and faster and the decision on how to solve the PFAS in many locations.
Excellent. Thank you, Angelita. We are getting some great questions already in Q&A, so please keep those coming. We will be sure to answer either during the presentation or maybe at the end, but either way, we'll be sure to address those. So we talk about some of these challenges in figuring out the risks associated with PFAS and how to treat for PFAS and how to figure out what you need to do, how long it's going to take, how much it's going to cost. And instead of talking in the abstract, what we want to do is show you what a sample project looks like when it's run through a technology like the Transcend Design Generator. So we're going to show you what a real PFAS scenario looks like. That in this case, we think about it as a utility, or if an engineering consultant using the software on behalf of a utility. And what that looks like, both from an inputs perspective, what it takes to create a PFAS treatment solution, and then also what the outputs look like. So what does the solution look like? What sort of documentation is provided once the software is done doing its thing? So I'm going to share my screen so we can go ahead and take a look at a real project. And we should be good. Yes. All right. We're in good shape. So what we're going to do is walk you through the steps of running a real PFAS treatment design. And I'm going to pause at different points in time so that Angelita can speak about why some of these features, some of these knobs, if you will, some of these, these ways of tweaking a design or some of the inputs can lead to a better outcome on the output side. So why a utility or why an engineering consultant might want to use a technology like this, or how they would use a technology like this for their specific project. So to start, when you log into our software, as I mentioned, we're a team of water and wastewater treatment experts. So we have a wastewater treatment plant design generator, which is sort of our bread and butter. PFAS is a bit newer. We also do electric substation design. We have some other engineering applications we call a tool shed. And we have our drinking water application. In this case, this is for PFAS treatment, as well as booster stations and pumping stations. Today, we're going to focus on PFAS treatment design. So, whoops, we lost it there. Let's see. Come back. Let's see here. Oh, boy. All right, let me oh, here we go. All right. So once you log in, we click on our drinking water dashboard, and we're going to create a new project specifically for PFAS. So right here, the first thing you're going to do is you have a number of options that you can inputs that are specific to your project. So in this case, you have the asset owner, the utility name, a project name. And then one of the things that's really interesting is because we work globally, oftentimes we're dealing in both metric and imperial units. Some of our dosing also is in metric or imperial, depending on what we're analyzing. So as we walk through this, you'll sort of see how the software works and what some of the options look like for these. So Angelita, as this is filled out, anything in particular you wanted to mention on this screen?
Sure. So in here, and I believe everybody's seeing I'm now confused on the two screens in here. All right. So for the design, so in this, for those of you who are in the US, of course, you can preset that you are in the US, and also preset if you only work with one state, your state that you work on. You can also create, if you do several states, create other projects and preset those as your other states where you are located at. And also the preset on the units can also be done ahead. And so in the US, you have your strange units sometimes. And then in Europe is going to be a different story. But that's pretty much how it works in the first, very simple.
And so for this project, we are going to stick with a site, basically a greenfield treatment site. So you might imagine you have your existing plant, and then you want to build on new capacity to treat for PFAS. That's what we're going to focus on today, because we don't have, quite frankly, enough time to show you how we would do it for a brownfield site or a site with existing assets. Both are possible. Today, we're going to focus on a net new PFAS treatment facility with a greenfield site. So once we've entered some of our basic input information, we then get to things like our design criteria. So this is the source water type and various other types of requirements related to the water that's being treated. So Angelita, anything you wanted to talk about here?
In here, what you can see is that we have developed these for groundwater, could be surface water as well. For now, Adam has the groundwater. And somebody asked about other applications. Yes, there are other applications that Adam mentioned in wastewater. In this case, this is the modules, is a PFAS side. At this point, we do have ready both granular activated carbon as an option and ion exchange as an option. So in this situation, you could run one scenario with granular activated carbon, and then rerun another scenario with the same inputs on the ion exchange, allowing you to be able to compare the two. We'll get to that later. And having that opportunity to be able to see which one will be more cost effective or more effective in overall by having those two technologies in there. Unfortunately, still, we don't have the membranes, but that's not necessarily a drawback. That's why we also have Nick in here.
All right. So then once you've selected a few of these basic inputs, as an example, Angelita mentioned the granular activated carbon or ion exchange, then we start to enter our water quality parameters. So these are things like pH, TOC, alkalinity, hardness. As we go through these, of course, Angelita, anything that you wanted to mention in here, feel free. I also see a question I think it's relevant to talk about right now. Emmy asks, what about blended water sources? So Angelita, if you want to talk to that as this plays, feel free.
Yes, so strictly for this tool, what we have is groundwater is an option. Groundwater is the one that is not affected, not under the influence. For that blended option would be the more suitable for the surface water, and we'll have to tune this where Adam is showing, tune up the input parameters. And that's also depending on where the location of your solution is, right? But yes, blended will be considered not anymore as a groundwater alone solution. That's a good question.
All right. So you can see here that the software will require a couple different fields, particularly if you're treating certain types of PFAS compounds. If you have those, you can input those here. There's also an advanced tab, which I believe we'll be clicking on shortly. Oh, and we lost it. Here we go. Let's see if it will come back. 1 second.
So what I'll cover that. So the input parameters are parameters that you typically have in your sampling protocols and probably with reporting to your regulator. The additional parameters are parameters that are maybe competing with your media. And so in case of media, some of those parameters may be that you have 1,4-dioxane, or that is iron, manganese, additional chloride. Situations where your media will be, will be competing against the PFAS, and so that could be disclosed in here. If you don't have them, you could leave them empty. No, that wouldn't cause an issue.
So one of the things that we like to feature is the fact that not everyone is an expert in water treatment. And I certainly am not an expert. I know enough to be dangerous, but there are so many variables when it comes to treating water. You really need a solution that can help guide you through that process to make sure that you're not making any basic mistakes. If you notice, we tried to click to the next screen, but we forgot to enter our input parameters. And in this case, the software is telling us you must enter one of these things in order for a design to process. In other words, we want to prevent you from either not from entering poor data, or you need to give us data that we don't currently have. So that way we can guarantee basically that we can trust the outputs, that the software is using valid inputs. In other words, this whole garbage in, garbage out equation, we want to prevent garbage from coming in the first place. So that's what becomes very useful in a web-based software like this one, is when you make a mistake, or if you're about to make a mistake, it won't let you. It'll prevent you from doing those things. So that's always something that we like to talk about. So you see here, this red text is where some of these sort of errors will pop up and tell you, hey, something's not right here. We need to change something about the way that we're doing this. So what you'll see is we're going to enter in some of those values, and we'll make sure, again, we're highlighting that error text here. We'll make sure that we input those values appropriately so that we can then move to the next phase of design. Here you can see us toggling between some of the input units. In this case, we're going to use parts per trillion. And now that we've entered that, we move on to the next screen. So we're going to start with the removal rates. Annalita, feel free to talk through this as you see fit.
Mm-hmm. Of course. So in this case, Adam has selected removal rate that he wants, whatever he wants to remove. But there could be options on doing it based on % remove or a target value. Like if you want to go to non-detect, you could put that in there. So it could be the two ways. Whether you select a target, a % remove, or a target, it would work. It would run the system. And for this case, you have a source, your rate of design flow rate. Typically, it's whatever you use for the design flow rate. I know some states will require some saying, okay, you need to use the peak, and others will be saying you need to use your permitted capacity. There is some debate on that because that permitted capacity may not be the one that you can achieve, and so you may be over designing. Well, this tool also could help to give those scenarios and have a conversation with your regulatory agency, and see if there is any way to alleviate or to modify some of these parameters just by seeing the results and how different how over design that could be if it is left that way.
Excellent. So now we get into some of the specifics about the technology we chose. So in this case, we chose a granular activated carbon removal technology. And so if you want to add some of the specifics around your particular equipment or your particular technology, this is where you would do that. So we'll go ahead and continue running our design here. So right now we're highlighting, again, the specific preferences of this particular technology. We're selecting lead, lag, or parallel as far as vessel configuration. We have a number of other advanced inputs that you're welcome to use. So this could be minimum dimensioning or low energy, if those are options that you're trying to consider for your project. You can look at the different types of loading rates. You can look at the heights and different ratios for things. These are all options. You don't have to do anything with these if you don't want to. But the more data you provide, the more detail, the more accurate the outputs will be for your particular project. Annalita,
and
anything on the... Yeah.
Yes, I want to mention something about height. It may be, oh, why do you put that, right? I came across a situation where, we were debating about whether the vessels will physically fit on the current infrastructure that it was in there, that there was a space, but we didn't know if it was going to fit, right? So by limiting that volume, then or the height or the diameter, it really helped to visualize where the actual vessels will be going. And if I'm able to buy those vessels, or do I need to go for a customized order, which in turn it will take longer time and also will be more expensive. So that is a great tool to be able to understand ahead how and where you can fit, and if your solutions will fit the current buildings where you want to place them.
Excellent. Angelita, this is definitely right in your strike zone, if you will. The different types of targets that we're looking to remove from the treatment or with the treatment process, and some of the options in here. I'll go ahead and play, and then feel free to speak to those too. Oh, if we don't lose it again.
No problem. So yes, so the tool is designed to fulfill the conditions on the new PFAS rule. So it is set to do that. There are the 6 PFAS that are being discussed in the new rule from EPA. So those are set for that. But also you can set them based on you can add other PFAS as Adam showed before. You can also include in there the rest of the information that is in here is what type of the media, what is the disposal on the media, or the way you're going to dispose the media, what is the distance to the disposal. These questions are important because it will help to make decisions on the operational side. One thing is the capital, and that's precisely this tool helps with the capital, but also operationally, we need to think what is the balance between choosing between ion exchange or JAC, for instance. And that there could be a good decision maker point to be able to assume one technology or the other technology.
Angelita, we had a question from David. He asked can different types of GAC and ion exchange media be specified?
At this point, we don't have it that way. Sorry, excuse me. Yes, we do. We do have it. I believe we specified somewhere in there. I think we did, but it may not be public yet. So we have that. We have been working on the different, I know the GAC, they have some qualities, one versus others. And also that will influence the operational costs, and also will influence the removal processes. So we did play with those internally, but that's a good point where I see also the value of having vendors engaged because their efficiencies and their removal efficiencies will be, we can discuss them together. So let's say that if you are a user and you have a vendor A and vendor B trying to say, okay, I have this issue, but here are my solutions. You can physically just sit and check those question marks through the vendor's specs, and then compare the two options on carbon or the two options, or that is another advantage of this tool, is that it's not preloaded, but you could work with the vendor to do that and then see the results yourself comparatively.
And we're also, shameless plug, looking for more vendors that have this type of equipment or technology to incorporate into the software. So if somebody somewhere in the world, whether an engineering consultant or utility, runs a design and they want to look at different choices it's always nice for them to have multiple options to compare against. And it's a great way for equipment vendors to get their name and their equipment in front of utilities and engineering consultants all over the world. Along those same lines, Terry asks, I might have missed it, but did Angelita help create this software, and how has the software been tested or verified? I will answer the second part, and then Angelita, I want you to speak to the first. You'll see here in a second that the outputs that come from the software, one of which is a fairly detailed technical description, which outlines all of the calculations that are used that the software used to then come up with the outputs. So it can actually be every single decision that the software is making when it creates these outputs can be traced back to an actual first principles engineering calculation or rule of thumb. So, in our case, you might say, how were the number of vessels selected? Well, for this particular vendor, they have their own equation, or based off of this chapter in this textbook on activated carbon vessels, here is the calculation that was used. So every single thing can be tested and verified.
Yes. And to answer to your question, Terry, yes, I helped to build this software alongside fantastic team from Transcend. And I'd say I actually worked with one of these team members in the past before joining and helping advising Transcend on this. The entire tool. It is not one that is going to replace design, but it's one that is going to help you guide and make your life easier before you go into the commitment on, I'm going to go into a full design scope and seal with an engineering firm, or an engineering firm sealing with a client. It will help assess both ways. One is making sure that you get the right outcome from your what you are getting from an engineering firm, but also an engineering firm can be more certain about how much time it may take for them to build something that is before going blindsided, right? So it is a very good tool. And yes, I helped put it together.
All right, we are running a bit short on time, so I want to make sure we get through the rest of the demonstration. Some of these options, like distance to disposal site, as an example, will determine the overall the O&M costs of this project. So those types of inputs are important. Relative to different vessels or the different technology choices, things like inlet pressure, required pressure after treatment, these also have an OpEx impact, which is important for the cost of the project and the outputs that are generated by the software. And then here's some of our CapEx estimates. So obviously, capital costs differ widely across regions. Even within different states, you might have different vendors that have specific costing, or maybe you're a large utility that has some sort of preferred relationship with a vendor. That's where you make those types of decisions in the software so that the outputs are aligned with your particular scenario for your utility or the consulting engineer working on behalf of the utility. Once then that data is entered, there's a basic process scheme that's created for what this new treatment system will look like. And you can see some of the details about that treatment system on this screen. If there's something that you don't like or that you wanted to modify, you're able to do that in the screen as well. So it sort of gives you like hey, before you want the software to do its thing, make sure that you're comfortable with all the inputs that you provided so that when it generates the output, you're happy with the way that it looks. So this basic process diagram or block flow diagram is created. And then when you hit run design, that's it. There's no more manual intervention involved. So when run design is pressed, the software then does its thing, and we're gonna X out of it now. And I'll stop sharing my screen. The software then starts to run a complete design package. And what do we mean by a complete design package? Well, a couple of things happen. So the first is you are going to get an email notification, typically within about 5 minutes or so. Again, this is a very quick process, and that's the title of the webinar, PFAS, Tackling PFAS in Minutes. This literally takes 5 minutes to come up with an answer after you've put your inputs in to the software. So you get an email notification that says your design is ready. And then once it's ready, you'll see in your dashboard that we had just shown that your projects have been completed. So in this case, we have these 2 projects that were done. The status is complete. And then you can go into those and do what you will. So you get, again, a full set of output documents. I'll show you here in a second. You also have the ability to very easily modify a design. So if you wanted to change something like the treatment technology, you wanted to go from GAC to ion exchange, you wanted to change inlet pressures, you wanted to change some of your water quality parameters, this gives you the ability to play with those, to come up with multiple answers, to do something that we often call optioneering or value engineering. You're able to do that very quickly. Instead of having to run back through process models, go back and forth with a client, you can bring all of that data very quickly up front in the earliest phases of projects and get that work done very early on. So relative to the outputs of the project, again, I mentioned this technical description or a preliminary engineering report. You get schedules for the construction of the project, you get a bill of quantities, and you get a 3D rendering of the site. So you get your ortho views. And what's especially cool, and what I like, and Angelita, I want you to speak to this a bit as well, is that when you have things like views and renderings in the concept phase of a project, what value do those bring to a utility or to an engineering consultant? So I'll flip through those and you can sort of speak to that.
Yes, I mean, first of all, is that you can see before everything is finalized that, okay, we're talking about minutes, right? We did this, it's minutes, let's say an hour, 2 hours maximum. So you can see how your final design is going to look like before you have to wait for months to be able to get those through. And then you can make decisions like in here, you can place them into your actual facility and then see, is this the right place where I want them to be, or maybe it's going to be having to be moved. And today you can already, we're not going to do it here, but you can already move them, like literally move the vessel or move the entire design, and everything will recalculate for you. So those are things that are giving you value and time. That's one. Two is the fact that you can plan for your capital expenditure ahead. So if you decide not to do take care of the PFAS removal in this year 2024, maybe 2025, 2026, you can place them in there and they'll still see that's the location where you're going to go. Permits is going to be mobilized and start on that location. And so and you can also talk about this with your regulatory agency, making sensible, it's a sensible location, for instance. So that's a way to gain time and to gain certainty of what you are going to do ahead in the game.
So as you can see, some of these 3D renderings that are generated by the software will give you that quite frankly, what I think is a beautiful sort of view of what this treatment system will look like once the project is all said and done. And again, as Angelita mentioned, in the earliest phases of design, it brings a number of benefits to both the utility and the consulting engineer. So again, here's some more of those views. And I think also what's really interesting is that if you run two different projects with the same parameters, you just change the technology that's being treated, you can very quickly visualize the difference between the two. So you can see the GAC facility versus the ion exchange facility look very different. They're going to have a different site layout and footprint on the site. But of course, there are other parameters there that you want to look at too. So it's not just about the 3D visualization, but when you have the data, like I'm going to show you here, you can very quickly say, all right, from a number of vessels standpoint, which means it's probably a higher equipment cost, from a depth of the beds, as an example, of the estimated footprint, these types of things, you can very quickly make the comparison and make decisions about what needs to be done for a particular treatment project. Okay, anything else here, Angelita, before we pass it over to Nick?
No, the last part that I would say is I was once a consultant, and also I was once working, or many times working in the industry as the client, right? To me, there is nothing better than having technology helping us to make decisions on time. And when I taught the Transcend team socialized the idea with me, I said, this is a no-brainer. This is something that is going to help utilities at this point, thinking my utility mindset, and also it's going to help other users, other use cases to make something that requires time, because now we need to change all of these really fast and respond to the regulation. but in a shorter time. We need to go out of the traditional way of thinking of how the process of design process should go. We're not going to get rid of the design engineers, but we're going to help the process to go forward, right? That's the key. We're working together, whether it's design engineering, there's design, or there is a vendor, to work together to be able to get to the endpoint faster and more accurate and more efficiently.
Excellent. Thank you, Angelita. We just talked about activated carbon and ion exchange as two options, but there are other options that exist. And what we want to talk about today is membrane technology specifically, and membrane technology that should be considered for your next PFAS treatment project. So Nick, feel free to take it from here.
Yep, thanks a lot, Adam. Yeah, I'm going to shift gears just a little bit. I want to talk to you guys about our membrane technology and how it can be used in PFAS treatment. First, I'm going to start with a little introduction just to what it is and what kind of makes it unique. So here we are. While NX Filtration manufactures a range of filtration membranes, nanofiltration, ultrafiltration, and microfiltration, really our flagship product and the product that's the most beneficial in PFAS treatment is our hollow fiber nanofiltration membranes, specifically the DNF40 and the DNF80. So these membranes are in a hollow fiber configuration, but they're significantly tighter than your traditional ultrafiltration membranes. You can see here with a molecular weight cutoffs of 400 Dalton and 800 Dalton, as opposed to your typical 150,000 Dalton ultrafiltration, usually like a 0.2, 0.3 micron cutoff. And having this tight pore size allows for the rejection of color, dissolved organic carbon without coagulation, turbidity, and organic micropollutants, including PFAS, without, like I said, without coagulation or heavy chemical use. And so one of the reasons these membranes have really gained a lot of attention during their commercialization in recent years is because they have this hollow fiber configuration, but then they, similar to a UF membrane, but then they produce this permeate similar to what you'd expect from say a spiral wound NF. And so you kind of can combine the advantages of multiple technologies, in addition to the fact that these are not polyamide based membranes like you might expect from a standard RO or spiral NF. And so for that reason, they have a much better stability in the presence of oxidizing solutions such as chlorine, allowing them to be cleaned with chlorine. So kind of along the lines of that, I have this slide here, which just kind of shows you some of the differences between what you can feed to a traditional spiral wound NF membrane and then the hollow fiber nanofiltration membrane. In a lot of cases in standard water treatment applications with a spiral NF, you're looking at feed turbidity of less than 1 NTU, no suspended solids, low COD or very low TOC in the feed streams, and of course no chlorine in the feed stream and no cleaning with chlorine. But in the case of your hollow fiber nanofiltration, these membranes can be backwashed regularly, and it's a PES-based membrane with a polyelectrolyte nanolayer coating that allows for cleaning with chlorine with like the robust. It basically has a similar oxidation resistance that a polyether sulfone membrane would. So it's a very strong, up to about 250,000 ppm hours. So the combination of being able to backwash and clean with more aggressive chemicals allows us to treat feed streams that you would normally expect to feed into an ultrafiltration membrane, but like I said, still produce that high quality nanofiltered permeate. And this allows you to kind of, combine the best of both worlds and, combine these technologies in a way that offers like one single simple solution for a range of different applications, including PFAS. So here I'll show you kind of our general scheme for PFAS treatment, particularly in drinking water cases. Of course, in wastewater treatment, there may be like some different pre-treatment steps, but it's also very, very applicable for that as well. So the hollow fiber nanofiltration provides a robust physical barrier to PFAS while operating at about a 5 times reduced energy consumption and about 90% lower chemical consumption compared to a combined UF and RO-based membrane solution. And when you put this hollow fiber nanofiltration upstream of an absorbent, such as your GAC or your ion exchange, it's going to do the heavy lifting of removing. I think I saw a question actually in the chat from Amin. He said, do you suggest implementing other technologies in combination with IX, GAC, depending on water quality, technologies that can help removing the competitor compounds to help breakthrough time to make IX and GAC more viable? That's exactly what we like to see the hollow fiber nanofiltration be used for. It can be used to remove turbidity, like I said, dissolved organic carbon without coagulation, color, bacteria, virus, anything else that would potentially give you some trouble with your GAC or your ion exchange. So we see something like a 5 to 10 times, depending on the application, increased regeneration cycle, or stand time for your GAC or your IX, be due to using that high quality nanofiltered permeate water feeding the absorbent technology. And then on the concentrate side, I think we had a question about the concentrate management as well. Obviously, membrane technologies are not destruction technologies; they are separation technologies for PFAS. But in addition to that, we are concentrating up the TOC, or the total organic carbon, and the dissolved organic carbon in a way that included in that PFAS-rich HFNF concentrate, which then also increases the efficiency of say, a foam fractionation step when it's used on the HFNF concentrate. So like a fairly common idea for concentrate management. Once you've used this hollow fiber nanofiltration membrane, you've removed PFAS from the water, you sent it down to a downstream of the absorbent, which is going to do further removal. And so now you've effectively, your permeate or your effluent from that process is meeting your standards you need to. Then of course you have to deal with it on the concentrate side. We help to reduce that volume such that foam fractionation can be more efficient. And then, from there, looking at a destruction technology beyond that. And another benefit is that, the hollow fiber nanofiltration compared to something like RO, you don't have an extremely elevated TDS in your concentrate stream, which makes it very easy to manage and treat. So incorporating, hollow fiber nanofiltration into your water treatment trains will allow sites on the effluent side to meet current PFAS regulations and future-proof their systems against future regulations, and then also allow you for simpler concentrate management. And now I just want to end things by talking a little about our online projection tool. And so NX Filtration and Transcend have worked together over the past few years to develop a state-of-the-art online membrane design projection tool that allows for comprehensive simulation of the NX Filtration hollow fiber nanofiltration membrane. So clients can register an account online and have immediate access to this projection software, which will give them a very in-depth understanding of how hollow fiber nanofiltration will perform in all applications, including PFAS applications. And so one of the reasons here that this tool is particularly advanced is because it not only displays standard membrane projection water constituents that I'm sure a lot of you are familiar with how membrane projections are done. You usually get your ion breakdown and maybe some of your larger organic molecule breakdowns or something, depending on which manufacturer's software you're using. In our case, the software can be used the software allows for users to enter custom constituents, including organic micropollutants, into the software, and you add a little bit of information about those constituents, and then you get a estimated rejection for that organic micropollutant that you've added to the software. So this is, of course, going to include PFAS molecules. And so you can see here at the bottom right, I have it highlighted. Hopefully it's not too small, but this printout, this is some snapshots from the printout of one of the projection reports, shows these different PFAS molecules and their concentration in the feed and their expected permeate and concentrate concentrations, which is of course going to make it very easy for you to then take that information to whatever other technologies are being used, whether it's on the effluent side, if you need to know what your incoming GAC is, or incoming values are for say your carbon or your IX, and on your concentrate side, it'll also give you your estimation of your concentrate concentration. Not to mention, also it'll give you your TOC, total suspended solids, turbidity estimations, color estimations for both your permeate and your concentrate, which will then allow you, your any other technologies you're using on either the permeate or concentrate side to, have a good understanding of what water quality is going into those additional process steps. So of course, it's going to provide all the other information that you might have come to expect from membrane projection, including hydraulics, energy and chemical consumption, and of course, a full breakdown of the water quality. So we see this as a fantastic partnership between NX Filtration and Transcend, like-minded people and companies working together to provide these innovative solutions. And so this software it's very intuitive, easy to use, available directly from the NX Filtration website as well.
All right, Nick, thank you so much for the presentation. Our email addresses are listed here. You can feel free to reach out to myself or Nick at any time. We really appreciate the engagement and the emoji interactions. Again, it's been fantastic. I will say it's unfortunate we do not have enough time to get to all of your questions. We will do as many as we can while we're here right now. So Nick, I want to be sure there's a couple related to NX's products, and maybe you saw them in the Q&A. Feel free to address any of those that you want. So relative to like your energy consumption, some of the composition of the membranes, the 5-log credit, all of those things.
Yeah, so just taking here this first one, what are the typical cleaning systems for the membranes and the waste products produced? So we will clean these membranes very similarly to how you would clean a hollow fiber ultrafiltration membrane. The one thing is that we run these in a cross-flow filtration configuration, so you're not dead end running like you would a UF. So our backwash frequencies are a little bit less. We're usually looking at like once every hour to maybe once every 2 hours, and depending on the application, it could be up to like every 4 hours, 5 hours. And then on the chemical side, you're looking at like usually around somewhere between like once every 2 days to once every week. You're doing either a 15-minute or half-hour high pH clean with chlorine, so about pH 10.5 to 11, with about 200 ppm of chlorine on the feed side of the membrane. And then if there is any potential for scale production or scale formation in that water, you're looking at potentially doing an acid flush as well. Same thing, it'll be around pH 2.5 with either citric acid or hydrochloric acid on the feed side of the membrane. Is NX Filtration energy efficient and can be used for domestic water treatment? It can absolutely be used for domestic water treatment. That's another sweet spot application for our membrane. So two of our biggest sweet spots are, municipal drinking water, where you're taking surface water, minimal pretreatment, if any, going straight into the hollow fiber nanofiltration membrane, and then producing a permeate that is, in many cases ready for, chlorination and distribution. In some cases, you may just, on the back end have a GAC or something simple like that. And then on the wastewater side, if you're taking municipal secondary effluent, you're usually looking at something like a drum screen up front, so like a 50 micron drum screen going straight into the hollow fiber nanofiltration, and then from there potentially something like a advanced oxidation process before you've now got water of an appropriate quality for either discharge or reuse. Energy efficient. These are low pressure membrane modules. So even compared to something like a spiral wound NF membrane, you may be looking at say 100, 150 psi. and potentially higher depending on the application. In our case, we have a maximum module pressure of 90 psi. So these membranes are operating, typical operation is around 4 bar, so right around like 60, 65 psi. We usually operate at fluxes of somewhere in the range of 20 to 35 LMH. So something like 10 to 20 or 25 GFD. So it's going to be very similar fluxes to what you'd expect from like a spiral NF, but generally operating at a little bit lower pressure. The target for these membranes, while they do get some like hardness removal and some TDS removal, the goal is really we're looking at organics rejection, color rejection, turbidity rejection, organic micropollutant rejection like PFAS. So we are, we're not increasing, we don't generally have extremely high osmotic pressures where we're then going to have to be very energy intensive. And I see this question here, what do I do with the concentrate or reject? Certainly this is a industry-wide problem. But of course, membranes are a separation technology. I think this question has come up a couple times in here. So we can, we concentrate the PFAS and we separate it from the main process stream. So you can use your permeate for whatever you need to. And then from there, this concentrate can be used for, like say a foam fractionation technology could be used to then further, do an extreme concentration step of specifically the PFAS, which then makes it, appropriate for the further destruction technology, whether that's electrochemical oxidation or high temperature alkaline treatment or supercritical water oxidation. And then the last question here I'll quickly jump to is you mentioned, hi Nick, you mentioned a 5 log credit. Does this mean you can guarantee an LRV of 5 through pressure decay test? Yes, the answer is yes. We do these membranes can be pressure decay tested inline in the membrane skid that we have, P&IDs for that. It's something that the membrane is certainly capable of. Whether in every application you are going to get credit for 5 logs, I think there's a difference between, we can technically prove a 5 log reduction. Whether you will in every state or every application actually get a 5 log credit for it, that it is a new technology. We're still working with regulators to, prove that the membrane integrity test is like, we need to kind of separate it in people's heads from ultrafiltration in that regard, so that we do get the credit for log removal that the membrane actually does achieve.
We are unfortunately out of time for today, but everyone's questions have been recorded and our panelists will try to reach out to you after the webinar. I just wanted to say a couple quick reminders that if you meet the attendance criteria, you can download your certification of completion now by clicking the ribbon in your toolbar. Also, a survey will appear when we end the broadcast. Please take a moment to share your thoughts. Your feedback is very important to us. And I just want to say a final thank you to our panelists and the audience for joining. We hope to see you next time.